Okay, Shoshana, sorry, you got the pizza. I was going to text you.
Yeah, I was going to text to see if
Yeah. Okay, so this is a minute behind. That's okay. And now I'm going to go to the meetup. And I'm just going to say, today. I think I will add a comment here. Yep. I'll just be able to say, for the live stream, right here. Okay. Now, I don't know if anybody's actually on the live stream.
Is there a Wi-Fi that we can connect to so we can try?
I'm friendly. It's supposed to.
That's supposed to do it? Okay. Mm-hmm. So the link is on the messages. I could email everybody, but the green says my mic is going. I can obviously tell my screen share is going. So I think we're good for now. All right.
Yay!
Yay!
And are we on time?
Well, it's 6:10.
Whoops.
But we had 38 people sign up, and there's only 6 people here. Is parking really that bad?
So parking now shouldn't be an issue, right? Because there's the meter stop.
Yeah, I don't know.
It wasn't so bad. Like, I found a meter spot.
There's
easy.
There's also another meetup just starting for big data on the same day.
Oh, there's a big data
80
meetup.
people signed up for it.
Oh, 80 people for a big data. So we've always had a big data meetup, but we've had a big data meetup, and we had a predictive analytics meetup, and we had, the data engineering meetup that a lot of us have been to. It's weird, huh? A lot of sprawl here on the big data group.
But the big data has always been this night.
They don't do it every few months.
Yeah, they're not regular. Yeah. So sometimes it's off Thursday. Yeah.
I purposely chose you guys.
Yeah. Thanks. So, do you guys know what book we're going to read together? Well, at least Scott and I are going to read it. So it's Apache Spark: The Definitive Guide. Did you see that in my email today? You did?
Yeah.
Did you guys buy it already?
No, I didn't bought it. I got a draft from the internet.
You got the draft.
Yeah.
Because it's expensive. So it's kind of a large book. It's 561 pages or 606 pages, and we're going to do it in 5 months. Typically, when we do books, we do them 100 pages a month. But this one we're going to do a little bit differently. So, yeah, $50. And you notice that it's 3.5 stars, but if you dive into the 1-star reviews, they're mostly complaining about the book quality. Some people didn't think that the printing, they're complaining about the printing and that some of the code is illegible. And they're also complaining that their books fell apart. Those might be valid criticisms, but they weren't criticisms on the content. And so we decided to go with the content. The other thing that happens in big data books, we've noticed, is that there are 2 types of readers. There's actually 3 types of readers to big data books. There are kind of old school DBAs and data professionals that know SQL and they know the ecosystem. And those guys don't typically complain a lot. And then there are data scientists that might have like an R background or a Python background, and they're trying to learn more about an ecosystem like Spark or something. And those guys don't complain about a lot. But then there's this middle group where they were like data analysts who are really good at Tableau and Excel. And they pick up, like a book like this is gonna have a lot of Scala and a lot of Python in it. And those guys complain a lot. They're like, I don't know what these words mean. Basically, they're not programmers, and then they got thrown into a programming topic. And even little things like variables and data frames are a lot for them, and then they criticize the book a lot. So all that to say that the 3.5 stars, when we read the reviews, it didn't really worry us. We were like, this book's probably good enough. Now, just so you know how I selected this book, I sat down with the product lead manager of Azure Databricks. So this guy is basically like a vice president for a product. Like these product group leads that they have at Microsoft, they've had them since like the 80s. And when they're in charge of a product, they are basically the equivalent of the vice president in charge of that product. Like they have a lot of authority. And so I sat down with the product group lead for Databricks, and I told him about our group, trying to get him to give us free stuff. And he didn't really bite a lot. But I said, how should we learn it? And he said, you should read this book. Everybody on the team read that book. And I'm like, oh, well, that's enough for me. Then that sounds good. We'll pick that book. And so we looked at the table of contents, and we decided it was entry level enough. Like, and that anything that was maybe a little more complicated or not entry level enough, we could augment in our lecture. Does that make sense? Any questions before we start talking about it? So here is the agenda that we're thinking of, and we'll post it on the group. The agenda is that we have April, May, June, July, August meetings. Uh-oh, cutting off. I wonder if is it just cutting off on the TV or cutting off on the stream too? Okay. So this is 5 months, and I know you haven't done your reading yet, but we're going to be doing chapters basically 1 through 3 today, which is part 1. So if we look at I'm going to go to my Kindle app, right? Here's my Kindle app. And come up quick. So I read on Kindle. He likes the paper copy
For all
because
books.
he
All fiction, I read on Kindle.
he has memory. He has a memory that's much stronger than mine, and so
Just visual.
when I say, "Hey, we learned that already," he's like, "Yeah, that was like page 50." How would you know that? So when we go to the table of contents, it's actually divided up into, and if you click here, see how it's like part 1 is a gentle overview of Spark, right? Part 2 is structured APIs. Part 3, low-level APIs. Part 4, production applications. Part 5 is streaming. Part 6 is advanced analytics and machine learning. And then part 7 is the ecosystem. So we have 5 meetings and we have 7 parts, right? So the idea was going to be that we would do parts 2 and 3 here, and then here we do part 4. And if you look at part 4, it's kind of a big part. There's a lot in, there was a lot in production applications, like these 5 chapters. And then here, we're going to do something weird. We're going to do part 5 and 7. We looked at part 7, which was the ecosystem, like language specifics and the community. And we're like, that's kind of a standalone thing. But this monstrosity, part 6, which is advanced analytics, that is a hard section. So we were going to save that to the end, part 6. And then be done. So that's the agenda that we're going to follow. And we'll put it up on the website. So today, part 1, we're going to cover with you, even though you haven't read it, because if you look at it, a gentle overview of big data and Spark. What is Apache Spark? An introduction to Spark, and then the tool set. Well, that's a perfect introduction. And you don't necessarily need to read about it in order for you to understand it. And then you can just read about it in a few hours after this meeting. Does that make sense?
Yeah. Is it Python based?
It's Python, Scala, and Java. And we are going to focus on the Python parts of it. So I don't know Scala. How do you feel about Scala? Yeah.
Not great.
Right. I mean, I know of Scala.
And we did it for the March 6th.
7 languages
Yeah,
in
7
7
languages in
weeks.
7 weeks. So
Yeah.
for that,
5 years ago or something.
yeah, it's probably 4 years ago, and that was for well, 2, right? So
Yeah, we did, as part of another group that we're in charge of, the San Diego Software Architecture Group, we basically did a new language a month. And then we did like Scala and Erlang and Clojure and 4 others, I can't remember. No, one was a dynamic language like Ruby, I think.
so there was also that weird one. This is the one that sticks in my head, which was like JavaScript, but was like 500 lines of code or whatever. That was like the simplest language. I can't remember what it's called now. French. But,
French.
So anyway.
Yeah. Anyway, there's one.
So Scala is a functional language, and the idea behind Scala is that everything is immutable, which means that once variables are instantiated, they cannot be changed. That makes for interesting programming. Primarily, the purpose of having immutable variables is that it makes multi-threading a lot easier. And in fact, it makes multi-threading almost inconsequential, but it makes every other aspect of the language much more difficult. So Scala, we're not going to focus on that. We're going to do Python because we've already done Python and TIG before, and because Python has an easier learning curve if you're interested in learning it. There's a lot of things about Python that make it very easy to read. Specifically, Python requires formatting with white space. Somebody have their hand raised? Yeah.
Just want to confirm that the friend of mine was joining in on the stream said it worked.
It's working. It's working. Okay.
Yeah, I saw that as well, and it's not cut off.
Okay.
And furthermore, for the record, Ruby, right there,
Yeah.
IO, Prolog, which is so super weird and not at all useful, Scala, Erlang, Clojure, and Haskell. The reason why I didn't remember Ruby is because Brett and I had done a couple projects in Ruby prior, so we were maybe, you know.
So we're going to go to like the best presentation tool ever made.
Paint?
Yeah. And we're just going to talk about, why Spark, right? Why is Spark cool? For a second. So, yeah, that's good. Okay. So, just so that we're all on the same page, how many of you have worked with massive parallel processing systems before?
I do.
Three of you have. And so the rest of you have not worked with an MPP before, right? Okay. So do you mind if I just take a minute and describe what an MPP is? Is that okay? Okay. So if you have a unit of work like a job, in fact, they're called that, and all MPP applications, they're called jobs. And a job is just a script. It's just a whole bunch of code that you're going to run, okay? And what you're going to do is you're going to want to run that code across multiple servers, right? So that means you're going to send that job to that server, and to that server, and to that server, and you're going to ask for a response. And then you're going to take that response and you're going to combine it into one response, right? That's the idea behind taking a unit of work and spreading it across multiple servers. That's popularly called scaling out. And if you think about what we're doing when we send that job to multiple servers, is we're trying to send the job to work on the data that is residing on that server. So if you take one large job and you move it around multiple servers, that's called mapping. And if you take the answer and you combine the answer into one answer, that's called reducing. And that popular notion, map, reduce, is at the heart of all MPP systems. It's the heart of Hadoop. It's the heart of Netezza, of HP Vertica, of SQL Data Warehouse, of Google BigQuery, of AWS Redshift. They all do some sort of thing like that. The other thing that big data systems tend to do is rather than requiring the job to know what server to run on, the job will create what is sometimes called the head node or the name node, or they call it the controller in Spark, right? They have it, whatever they call it, there's some like node in some server in the beginning that keeps track of what data is on which node and which node is responding to them and which node is slower than the others and how they're performing and things like that. So every big data system, whether it's BigQuery or Redshift or Netezza or Vertica or Teradata, they all kind of do the same thing, right? Now, the reason why we don't write all this by hand, like I could write this by hand. If I had 5 servers and I had a job and I wanted to send it to 5 different servers, I could do that myself, right? And if I wanted to, I could keep track of what data was on which server by just creating a partition table. I could write that by hand, right? But when you think about what you do when you take a job and you move it to multiple servers, is you really increase your point of failure. So if you have one server, you know, disks can fail, network can fail, memory can fail, right? But if you spread it out to 5 servers or 10 servers or 100 servers, you're really increasing the number of things that can fail across the entire system, right? Pretty massively. So what you need is a framework that will tell you which node seems like it's failing, which node isn't responsive, which node is sending off alerts, which node needs you to retry, you know, all kinds of things like that, right? Which one didn't return anything, which one has no data, right? And so you don't want to write that code. And so that's why people like open source frameworks, because the authors of those frameworks have thought through all the things that can go wrong when you send a job to multiple servers, and they are continually adding features to make your life easier, right? So that's the heart of Hadoop and the heart of Spark and Kafka and you know, Redshift and Azure SQL Data Warehouse. That's what they're doing for you. Does that make sense? Okay. So the big question here is, why Spark? Well, if this is the typical way that we do MapReduce, you know, send all these script to every server, have them process, and then get the result and combine it, right? Does that sound fast to you? Does that sound quick?
It's a trick question.
Depends on
Yeah.
how it is organized, I guess.
Yeah.
Yeah.
Well, in most big data, if you said, hey, I've got a SQL server here, it's a big beefy SQL server, or you know, Postgres or whatever, and it has 1 billion rows, believe it or not, that big beefy SQL server will probably be faster than a distributed system like this over a small to medium amount of data, right? It'll be faster. And you'd be like, well, if it's faster, then why would we ever do this? And the answer isn't that distributed systems are faster than single server systems. It's that when distributed systems slow down, the solution to that slowness is predictable, meaning just add a node. Add a node, it'll be fast again. That's not really true for a single server system. In a single server system, the answer to why did it get slow could be like incredibly complicated, right? We've all tuned, or maybe we haven't all tuned, but many of us have tuned single server systems, and you've asked yourself, that thing was fast yesterday and it's slow today, what happened? And the answer can be like incredibly complicated. In distributed systems like Hadoop, the answer is typically not as complicated. Believe it or not, the frameworks are pretty simple once you understand what they're doing. There's not a lot of sophistication there. And so when it slows down, it's probably just like, we either need to add some
We're trying to do
hardware.
too much per node.
Yeah, we're trying to do too much per node. So why don't we just add a node and distribute it again and see what happens, right? Okay.
So what do you define as being too big and to switch this kind of architecture?
Well,
That's
so
the big data question.
there's
When do you move
there's
to
a couple
something
of-
like this?
there's a couple of things to think about here, because Spark, remember my original thing was why Spark, right? That was my original question. Now let me keep writing that up while I draw. Why Spark?
Because they duplicate nodes.
Yeah, you can duplicate nodes for fault tolerance. Yeah, most frameworks allow you to do that.
But most of these systems don't necessarily duplicate them.
It's
as
not the same way
overlap
we
them.
think, yeah, they overlap.
They overlap them, right? So that the data, a particular row is there in multiple nodes, but they don't have a 2-to-1 ratio.
It's not mirroring, it's more like striping.
Yeah.
Striping with parity. Okay. So the first reason why Spark is because typical distributed systems were not really interactive. You would create a job, you would submit your job, you would wait some amount of time that everybody considered was too long, and then you'd get a result. And that lack of interactivity meant that the feedback loop was too long for when you made a mistake. And it was really hard to debug, and it was really hard to create solutions that were fun to write. And so we wanted to shorten the feedback loop and make big data solutions a little more interactive. Okay, that's one thing. That's one reason why Spark. So we'll write that down. We'll write interactivity. Now, you just asked a question, and I'll repeat it for the microphone. He said, when do you know that you need a solution that's distributed like this? And that is a complicated answer, by the way. But typically, where I've had customers move from a single server system to a distributed system to an MPP, a massively parallel processing system, is when they felt like their existing solution was too fragile, meaning it was breaking all the time, and when it broke, the recourse for fixing it was too long. So here's a good example. I have an ETL, in an old school system, I would have like ETL here. Here, I'll do another paint just to draw this up. So an old school ETL system says that we have a source system here, we have a destination data mart here, and we have what we visualize as a pipeline streaming records here, right? And we might be doing transformations in this stream. So that creates ETL, extract, transform, and load. And in single server systems, if something breaks in the ETL system and we have to redo it, let's say that that pipeline takes 5 hours to run. We find out at 4 in the morning that it broke. We rerun it at 4. Now the data is not ready until 9, right? That might be okay. If that's okay, then a single server solution might be working for you, right? But what happens if it's 8 hours to run? And we run it at 9 p.m., we find out at 2 that it broke, we rerun at 3. Now we're not doing anything until noon or 1. If there's 300 analysts on the solution, something's wrong, right? So that is a typical case where people are like, I think we need to parallelize our work here, right? This is our remediation for when this breaks and is too fragile is disrupting our work, right?
Yeah, I mean, not to detract from that, because that's totally true, but the simplest case is where your one system, your simple system, just can't do it.
Yeah.
Like it just is not
So it's a
possible.
much smaller answer than just says these numbers of records at this size of table, that whatever you have cannot handle the load that you want in a reasonable amount of time.
Well, and it could be the load. Most commonly, it's the load, right? There is another issue in that the business says, well, we're getting data from so many different data sources that we can't predict the number of data sources we'll be getting data from. And we need something that will work for all the data sources. Now, the problem with traditional ETL solutions is when you bring a data source online, I'm going to quote you an amount of time before that makes it to the data mart. And that amount of time is typically measured in weeks, right? In a big data solution, believe it or not, even though it's distributed, it is typically faster to get data from a new source into the data mart. And the reason why it's faster is because big data solutions follow a notion. They follow 2 notions a lot of times. The first notion is they say, just leave the data where it is, which means if you bring on a new data source, whether it's JSON or Parquet or CSV, when we copy that from wherever the vendor is, let's say it's Salesforce or it's some new vendor, or the US Navy, or somebody's going to give us a bunch of data, big data solutions tend to say, whenever the data comes in, just leave it there. Like, don't move it. And that lack of moving it gives us a little more resilience. It allows us to manipulate the data without worrying about what happens when we make a mistake, because we were leaving it in the original location anyway. So if we make a mistake, we'll just redo it because we're leaving the data there. Where the data movement is what makes mistakes so costly. It's what means that if we make a mistake, we have to redo the whole movement. And if you're trying to move, 500 terabytes of data and you make a mistake, that's a big mistake. If you leave it where it is and you make a mistake, you can kind of redo it and not feel the pain as much, right? Now, the way they are able to leave it where it is and still work with it is because they follow a notion called schema on read, which means in a typical ETL solution, we create the schema that we want, and then we pipe the data into the schema that we want. In a big data distributed solution, we have a metadata store that traditional relational databases do not have. And that means that we can leave the data. We brought in 50 terabytes of CSVs. We put it into a distributed solution, right? So we handed off the CSVs to this large data store and it distributed it correctly, right? And then we defined a metadata layer over that distributed system. And then we let the analysts go look at it. And the analyst looked and said, that metadata layer is dog shit. Like, do it again. Well, that means that we're defining our tables in the metadata store, and the analysts are looking, and they're like, that's good, now make it fast. And once they say it's good and it's ready to make it fast, then we can do more of a traditional ETL. Then we can have ETL read out of the metadata store and then basically populate a data mart off of that that's now saved and structured and ready for them to go. And that data mart could be a relational database, or it could just be a new file system, with a different set of formatted files that are sitting in the big database like Redshift or like Spark, or it could be Tableau or Power BI or somewhere else, right? But the point is that metadata store allows us to firm up the schema that we like instead of guess what we want. And then once we know what we want, then answer the question, is this fast enough? And then make a decision on how we can make it faster from there, right? So anyway, I said that the amount of data is too big and that it's too fragile. I said that maybe the business has said, we don't know where our sources are, and we need something that's a little more resilient as we bring new sources online. And then the third reason why they moved to distributed systems is that they were sold them by a vendor. And that is very common. So I've been to many organizations that are using big data solutions, and they didn't have a real big reason to do it. And you look at it and you think, well, you could have done this for $20 a month in an Azure SQL database or an RDS solution, but they're spending $4,000 a month because they were sold that they needed it, and they just chose it, right? So that happens a lot. It's happening at one of my customers right now. And we're thinking about maybe they're burning a lot of money, so we're thinking about moving to a different solution for them because the money's too high. But okay, and there's a lot of other reasons that marketing people will tell you, but those are the three main reasons I've seen. IoT, we see a lot, but that's again the data.
You say the big data problem, right?
Velocity, variety,
and volume.
Volume. Yeah. Okay, so we're back to answering this question, which is why Spark? The first reason for Spark is that MapReduce was a little slow and we wanted to be a little more interactive. That's one reason, okay? The next reason why Spark is because there's a data science to data engineer mismatch. And what I mean by that is what was typically happening is that when data scientists were looking at, and analysts were looking at data, and they knew they were going to have to deal with 50 terabytes of data. 50 terabytes, it was too slow for them. And so what they would do is they would randomly sample the data, and they would import it into their laptop. They would create a data set in R or Python or SAS or MATLAB or something, Excel, something, and they would interact with it there, and they would massage the data, clean it, prep it, work with it, visualize it, and then they would fine-tune their process, and they would say, okay, I think I've got something that I like. Can you please make it work for 500 terabytes of data, right? And the data engineers would look at whatever garbage they wrote, and they would try to productionize it. They would say, whoa, you're doing a lot of work here that is not good. And so let's clean it up and consolidate and make it resilient, and then make it fast, and then make it work over 500 terabytes. Well, that mismatch between the data scientists and the data engineers, it was elongating the project times. It was widening the project times. And the business didn't like it. So what Spark does is Spark lets the data scientists and the data engineers both use the same notebooks. And so what that means is when a data scientist works over data that they've stored in Spark, they work in a Python or R or Scala or SQL notebook. And they use those notebooks to prep the data and clean the data and organize the data and get it into a way that they want and visualize it. And then when they go to the data engineer and say, hey, will this work over 500 terabytes? The data engineer can look at the notebook and just clean it up there and then click, push a button and push that into production. So that is a much faster process than taking somebody's bastardized Excel spreadsheet with some R and trying to figure out all the dependencies and then put that into production. It's just a much more streamlined process. So what it does is it makes if we said, hey, start a project and end a project, right? It just shortens that time pretty significantly. So that's another reason for Spark. And then a third reason for Spark is that in other systems, when you wanted to use a language of your choice, you would have to bring in the module for that language. So let's say that we were using Hadoop, for instance, and you wanted to use SQL on Hadoop. Hadoop is mostly written in Java. And if you wanted to use SQL, you would have to bring in something else to use SQL against it, right? Yeah. But Spark has Spark SQL that's built into the ecosystem. And so you basically, what Spark did is it said, you can work in Java. If you're used to working in Java like Hadoop, you can work in Java here. But wouldn't you rather work in Scala or Python? And we'll have that as a peer language. Like everything will work all the time in Scala or Python, right?
Basically like API based. They're just building the clients for the same backend system rather than going around or bolting onto an existing.
Right, API based. And then, oh, you really like SQL? And you're not really a programmer, you don't really understand data frames and arrays and things like that, we'll give you a SQL dialect too that you can use. So it made the barrier to entry over big data much easier to digest for like an analyst or a data professional. Because unlike the SQL in Pig and unlike the SQL in Hive, the SQL in Scala is ANSI 2002 compliant. And so they're using joins and group by and having. Is that not true? Yeah, they said it was.
Right, because there is no one who is implemented the whole.
So they didn't implement the whole thing. So I'm guilty of reading marketing literature.
More to the scale, but it's not experimented. It's too big.
It's not SQL 92. Okay, so no windowing functions, no. Hopefully necessary.
But it's much better than Hive.
But much better than Hive. Okay, all right. Thank you for the correction. Correct me anytime you want.
Okay, another one.
Okay.
Hadoop also provides APIs for Python, even PHP and other languages through streaming.
It did. I was simplifying. In that case, I did know that answer, but I was simplifying for the sake of the example when Spark was originally written, which was 2009.
The difference is that Hadoop, in order to interact with it, you write a program, compile it to Java eventually, submit it, it will run, and provide you the results. So that was not very
Yeah, not very interactive. Right.
Which is your first reason.
Right.
And one other reason, if you're already using MPP, Hadoop or whatever, is Spark was just faster.
Right. Right. Thank you for that, by the way. So the next reason why Spark was popular and was gaining popularity is because of the big data notion that SQL and some of the SQL-based MPPs didn't have. Other MPP systems do, but SQL and SQL Server and like Postgres and MySQL did not have. And that is this, and it's a little bit complicated, but I think we'll get it. So, Spark. I don't know why. Okay. So if we were going to draw SQL, right? So we'd have a script and it would say like select ... right? From, join, right? And let's say we had multiple SQL statements here, right? When we submit those to an optimizer, whether it's Postgres or MySQL or SQL Server, there's some type of optimizer here. And that optimizer is going to parse, bind, compile, and execute, right? And it's going to issue a statement against a database, a storage engine. And then it's going to execute, and it's going to get the results back to the user, right? And it's basically going to do those 4 steps one line at a time. And it's going to get results, get results, get results, one line at a time, right? So in SQL-based languages, you would like hydrate a temporary table, then do some work with it, then some more work and some more work, one line at a time. What Spark does is what's called pushdown. So Spark lets you write a script, 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 and it is not actually going to run it one line at a time. It's going to lazy load the script, which basically means that you can create objects like a data frame. And then later on in another line, you can add a filter to that object and then add another filter and another filter. And what you're not doing is you're not going out collecting all the data and then filtering it on the client. What you're doing is you are basically creating the data structure that you're looking for, and then you're pushing it down to wherever the source is. So what that means is that here we have a where clause. I know I'm not explaining this very well. Here we have a where clause. Here we have a Spark cluster. That Spark cluster is going to go down to a relational store. It's going to push that where clause down to the store and then collect the data and do some work against it. And so what that means is that you have it's like what Link does. What's that called?
Lazy evaluation.
Lazy evaluation, right? That's right. Okay. Which is different than SQL. If in SQL you go and collect all this data and bring it back, you're going to bring the whole data set back. And if in subsequent lines you filter it, you're making the server do too much work. It's like getting too much data and then filtering it late. What Spark is doing is it's waiting until you actually use the object, and then it's optimizing your code and pushing to get the subset that you're looking for from the source. And it's lighter on the source system and lighter for the network and lighter for Spark.
Although in some databases, they use the index instead, just the index size.
Almost all row-based, unless you're talking about a columnar data store, they would all use indexes, right? It's just a question of where and when the execution is happening.
I just for information, I just looked up online. Spark has 47% of the market share, and Hadoop only 14%.
Yeah.
And then
What?
one of the big differences, so Spark much higher than Hadoop.
Yeah.
And also the
What?
big difference is that
Is that true?
that's what I'm reading here. And
I believe it.
You
and
do?
it says that one of the big reasons for Spark to be doing that is because they can also do a lot of in-memory processing.
Right, we haven't gotten to
hundreds
that
of
part.
times faster
Right,
than Hadoop. So
That's what I was saying earlier, and he's gonna get to it next.
right. Well, that's part of the interactivity is that it's doing an awful lot of things in memory. Yeah.
So
So it might be
when they first
same
came
difference.
out, they were boasting like 100 times faster than Hadoop on, there was some significant job, I don't remember, and it ran 100 times faster. And so people were like, 100 times faster? Jump, right? If they had said 5, maybe I can evaluate. But 100 times, forget that. I'm over there. So that was like a big draw. Later, it's not all cases where you can get 100 times faster. In some situations, I mean, I think even in this first section, right, they talk about narrowing versus, what do they call it? Narrowing versus widening or shuffling or something like that. And if you have a job that is like a shuffling job, and they can't do the in-memory stuff, and they have to persist, and so it doesn't do, so it depends. But if you have a simple, what do they call it? Embarrassingly parallel problem, right? Spark will kick Hadoop's ass. That's the short of it. Because it utilizes the memory where it can.
it's a good point to bring up to clients.
Also, the market share, I never trust anything that talks about market share, right? Because if they're talking about money, well, an awful lot of Spark is being published by Databricks, right? Where Hadoop, it's a little grayer, right? So people can use Hadoop without necessarily giving a company money. They can use Spark the same way, but they often don't. And then the other thing about market share is like, how do they know? Like, are they counting it by downloads? An awful lot of Databricks is used in the cloud. And so is Hadoop. Like, I just wonder what's true or not.
Can you explain the dynamics of Databricks with Spark? Are they just because they're the creators of it, or?
They are the creators of it, yeah.
But that's open source.
Yeah, so
It is, yeah.
it was open sourced and then companyized, organized.
Right.
Cool.
Like a lot of Apache and other open source projects, they said, yeah, there's an open source solution, and then as it widened in popularity, they started a company for support and training and.
This has been going on forever. Red Hat, right? Take an open source product, Linux, and then productize it. That's the word I was looking for.
Productize it. But the difference would be that Spark only has one company that's productized it, and that's the original creators of Spark started Databricks, and they're the only company.
Mongo.
Yeah, Mongo is a good example. Yeah.
It's been happening forever. So open source and they're productizing.
I think by now, Databricks is not the only company mostly contributing. I remember, I think
There's another Spark.
A couple years ago at IBM, I was told that I don't remember the number, but it was in hundreds of full-time employees of IBM who are working solely on contributing to Spark.
Yeah, for contributors, there are 30 companies that are fully employing contributors to Spark. Yeah. And the 30, I mean, Google is doing it, and so is UC Berkeley is doing it, and so is Netflix. And so there are, 30 companies with full-time Spark open source contributors, which is significant.
But there's a difference.
AWS and Microsoft both have Spark contributors too.
There's a difference between contributing and productizing, though.
Right.
So current committers: Facebook, Databricks, Palantir, Uber, University of Michigan, IBM, Intel, Databricks, UC Berkeley, Facebook, Red Hat, OAuth, I don't know, Oath? No, not OAuth, which is what I read it as well.
We know OAuth.
Yeah.
We work with OAuth.
UC Berkeley, or you mentioned them, LinkedIn, ClearStory, Cloudera, Intel, which I think are already mentioned Apple, IBM, again, Google. Yeah, so there's a bunch of companies here. And IBM is on here 1, 2, 3, 4 times. So four like different groups at IBM.
Yeah. Yeah. So, any questions so far about what we've covered? Does that make sense?
Thank you for explaining it clearly.
Yeah, you bet. So the vast majority of Spark work that I have seen, and I haven't seen a lot, so take that for what you will, but the vast majority of Spark work I have seen has been focused on ETL of large amounts of data, specifically in the cloud, whether it's IoT data, sensor data, or it's web logs, or it's just data pouring in from a vendor. They've been using it to clean and prep data to use it somewhere else. So as part of that, by the way, let me open up something else. The two largest cloud vendors are AWS and Azure.
Right?
Yeah, like Salesforce or Google.
Yeah.
Right. Yeah.
Or even Office 365. You're taking Office 365 out of Azure. Yeah.
Right. AWS has about 60% of the market.
If you're taking out
Office 365.
If you're taking out SaaS.
Microsoft will say Azure is the biggest because Xbox and Office 365 and SharePoint Online and Visual Studio Teams all use Azure as their engine. And so Microsoft would say we're the larger one, but.
And then Google would turn around and say Google Apps, right?
Gmail. But it is true, Xbox uses Azure SQL Database, and Office 365 does use
Azure
App Service. But anyway,
fuzzy number.
before SQL Server Integration Services, or Informatica, or Airlift is an orchestrator. Guess what ADF is written over? From a palette. Pipelines, they basically grab similar to the graphical things. They're called code snippets. They drag these Python code snippets down to a design surface, and then a template comes up and they fill in the template and it injects whatever they're looking for into the code, right? But they're both pretty much doing the same thing, which is they're making Databricks and Spark easier to consume. And the way they're making that easier to consume is, on this side, these are just managed VMs, managed clusters.
The more those you need, the more money they make.
Oh yeah. And then on this side, this is more like serverless. This is very similar to an AWS product that they released called AWS Lambdas. Azure calls their similar product functions. And the idea behind a Lambda is that you would write code, you'd put it in the Lambda, and then you would only pay for when the Lambda was executing, which meant that you didn't have to pay for the 24 hours of having a web server up and running. You would just have code that sat there idle, and then when you called it, you pay for the time it took for that code to run, right? So it allowed you to time slice your consumption of the cloud in much smaller increments. Where if you did it the old way, you would bring up like an Azure App Service, and you'd bring up an Elastic Beanstalk instance, and you would say, I want 4 cores and 32 gigs of RAM, and you would pay for that for as long as it was running, whether it was idle or not, you would pay for it, right? In a serverless environment, you only pay for what's running. So the difference is when you bring up a Databricks cluster in Azure or AWS, you pay for that cluster for as long as it's running, whether it's doing any work or not, you're paying. If you create a glue pipeline or an ADF pipeline, you're only paying for as long as the pipeline is running, which means the pipeline starts, it runs, it stops, you're done paying, right? You don't have to like take down a cluster or use some type of DevOps thing to manage it or something like that. You don't have to do that.
In some of these big data problems, what you're really looking for is an answer or an output, right? A set of output. And yes, you want that fast. And so you can expand capacity to 500 nodes. And yes, for that hour that it's running, you're paying a crap ton of money, right? But then as soon as the hour's up, you can shut down all of the nodes because you have the output that you need, right? So you can throw all those computers away, right? And you don't need to pay for them anymore, right?
Right. So ADF and Glue kind of handle that for you by not charging you for either bringing it up or tearing it down.
Right.
Where in a typical big data cloud solution, you would pay for it coming up online, sitting there while it waited for the job, and then being torn down again. And in AWS and Azure, you pay by the hour. So if you use it for 5 minutes, you're going to pay for the hour, which might not seem like a lot when you're dealing with one node, but when you're dealing with maybe 20 nodes, all of a sudden that you might not want to be charged that, right? Does that make sense? Okay. So yeah, Databricks is being used a lot. Now, here's another thing that's happening, by the way, and that is I'm a SQL Server. I guess I'm going to loosely use the word expert. So guru, yeah. I mean, I don't know at what level you're an expert. You never feel like you know everything, right? But I am flown around the world to speak at conferences on SQL Server. And if I say I want to write a book, they automatically publish it. So I guess at that point, maybe I'm an expert, yeah. Right? So, and I speak at the largest SQL Server conferences around the world. So in SQL Server wants to be an NPP solution. So in Azure, they released Azure SQL Data Warehouse, which is just like the MapReduce solutions that we talked about before. And it deals with unstructured data with a mechanism called Polybase, which is how it brings in Parquet files and JSON and CSV files and puts metadata store over it and works with it, right? On premise, they call that solution APS, or analytical, what is it? Analytical processing system.
Sure.
Okay. Now, these are very expensive. Both of these solutions are very expensive. SQL Server has recently been putting languages in its engine. So this is the full product. In the last version, it put an R engine in 2016. In 2017, it added Python. In 2019, it added Java. And that seems weird because everybody hates Oracle. Why would you add Java when everyone hates Oracle? But what they really wanted was Scala. And Scala is built on Java. So they did that because they are adding Spark to the SQL Server engine, which means SQL Server on-premise wanted an easy MPP solution, and they wanted a solution that allowed us to use Spark ML and Spark SQL. And so they took the open source project Spark and they shipped SQL 2019. It's not shipped yet. That might change one day soon, but it's not shipped yet. But when it does ship, it will ship with Spark in the engine. So that is a significant change for Microsoft. They have been more embracing of open source in the last, since Satya Nadella took over 6 years ago. And this is a big step. But why do I share this with you? It's because if you take this, Spark going into a relational engine like that, and you combine it with the fact that all of our ETL solutions are using Spark underneath it, the point is, we chose Spark as a topic for TIG because we feel like it has a bright future and it's being used by a lot of different companies for a lot of different reasons. And a lot of different cloud vendors are standardizing on it and a lot of database engines are using it. And so it's worth learning. It's got a very bright future. A lot of people are doing it. Yep.
So I was wondering, for example, one of the big things that PostgreSQL tried to do, and I think MySQL now is trying to do, is they basically link up with, for example, MongoDB for the document databases. They're trying to be the entry point for any data, including document-based. So what is the possibility? Because it seems that what you're saying is that Microsoft is trying to be the front end to Spark, so people will still use SQL Server and either run native SQL Server.
No, I don't think that's true. I do not believe that Microsoft is trying to be the front end for Spark. I do not believe that.
So then where is the link between Spark and SQL Server?
I think that Microsoft is trying to do maybe 3 different things at the same time. And by the way, I don't speak for Microsoft, so I don't know their intentions. I only listen to what they're doing and then assume their intention, right? And so my assumption on their intention is, one, Spark has very interesting machine learning and advanced analytic projects going on. And they wanted to bring those projects in so that they could be processed close to SQL Server data. That's without the data leaving SQL Server to do that work.
That's what I assume.
That's what I think is
from the get-go. Like that's what they're trying to do. Like you want the job to be close to the data, and so that it doesn't have to move a lot. And they have large sources of data already, and so it makes sense to bring that job close to the data.
Right.
Right.
That's one thing. The second thing I think they're doing is something you just said, which is you said MySQL and Postgres are trying to bring in Mongo and other JSON document stores in so that they're the front end. Well, Spark already has interfaces for Mongo and Cassandra and other NoSQL stores. And so if you wanted to unify the front-end API for all of those different data stores, and then you just put your own T-SQL API layer over that so that you're calling Spark underneath it, but nobody knows that, right? You have now made it so that SQL Server can ingest data from a lot of different places without the T-SQL developer learning a lot of languages.
Correct.
Yeah, so that is one intention, I think. But that isn't to say that they expect SQL Server to be the front end of Spark. I think it's just that they wanted to make those other data sources accessible to the T-SQL developer.
I wasn't thinking the end of Spark. I'm just thinking, especially for those of us who are really all-timer SQL developers, to be able to add those backends suddenly makes our value go even higher.
Yeah, right. Yeah, I think that's accurate. You're right. I think that's definitely accurate. And then the third reason why I think they did it is I think that they, and this is something they are not releasing, nor have they told me they're releasing, but it would not surprise me if they started to use Spark as an MPP solution that they could kind of codify under SQL. So they could like have a distributed storage of space without making the storage, almost like using SQL as the master node for a distributed system underneath. Okay. But I don't know that for sure. but it wouldn't surprise me.
Or like there's no good way, I know there are ways, but like there's no like great way for, you know, like sharding a bunch of SQL servers and getting the, you know, overlap of data, but not the 2 times the amount of data and that sort of thing. And so Spark does that sort of,
Right.
yeah, so basically still using SQL as the data store, but using it in more of a clustered type fashion.
Right.
Yeah.
And then the only thing that I can tell you, I don't like, because I'm being broadcast, I'm going to be on YouTube. I don't like hinting that what's that?
The mute button.
The mute button's right there, yeah. But I will say, like, if you look at what they've done here, where they brought R and Python and Java and Scala and Spark.
So do you mean store procedures can be written in Python?
Yes, that's what I mean.
Oh, fantastic.
Yeah. And store procedures can be written in Java. Yes, that is true, right? And they're seemingly bringing ecosystems on rather quickly, right? A year between bringing something in, right? They're getting good at this, right? It wouldn't take you to have any insider information of Microsoft to see that they're getting good at this, right? So then you could ask yourself, what else would happen in the future? Right?
Postgres
That's
was
all
big
I'll say.
competitors of this because Postgres was open to all those other languages in backend. And many systems that heavily went to Postgres because of that. So now if Microsoft bring all those languages inside, then it allows the diverse groups of developers all work on the same backend.
Right, right.
Yeah,
So
I can
they've had
use-
C#.
I can use PHP or R or whatever to talk to SQL Server from 2000s.
No, but on the store.
No, we're talking about
In the
in-store
store
procedures,
procedure,
right?
yeah.
Because it was basically, if you're a Ruby developer, it's interesting to be able to go to Ruby end to end, right? Like, that's interesting to the Ruby developer, and not have to learn another language on the back end, right? Right. Yep, that's exactly right.
Sorry to interrupt you.
No. But you did interrupt. This isn't a SQL Server class. It's a Spark class. But it is interesting that for Microsoft to do this, they've never done something like this before. So interesting to see where they're headed and what they're thinking. Okay. So on I had an agenda in my head of the things I wanted to cover. Do we want to cover a little bit about running the code samples?
Oh yeah, well at least talk about the Databricks, like the environment that you can run under.
Right.
And the code samples of the book, yeah.
Right. So if you look in the book, I have like the Kindle here, right? And I'll get rid of my table of contents and I'll like just kind of look here. They will start talking about the history of Spark, and then they'll start talking about using Spark locally. And they give instructions on how to install Spark on one machine. So Spark basically has, and I think they've got a drawing here that might, yeah, they have a driver process up here. Can you see that up in the upper left here? And then they have executors. And this is similar to like that head node or master node that I was telling you about before. But basically, you have that driver process that you start a session in, and you run some code, and then it's up to the Spark framework to decide which executors are going to be executing. You know, this is the distributed fashion here, right? And what this means is that we can mimic this locally on just one machine. And if it's just on one machine, instead of launching on separate servers, it just spawns multiple threads and it launches it on multiple threads. So what that means to you is that you can install Spark on your laptop and you can interact with it just like you would on a big data cluster, and it will just be multi-threaded instead of being on different servers. So you can install it right now if you'd like. Can they not hear me when I walk away?
That's okay.
To stream something's book.
Copyrighted material.
What does that say?
No, I was just
Are we
wondering.
allowed to stream copyrighted material?
So I'm not going to do the whole book.
Yeah.
And
That's what we care for.
yeah. That's an interesting thing. That might be why one of our videos got taken down by YouTube.
Could be.
Yeah, one of our videos got taken down. Maybe it was because we showed the book.
I mean, like,
Okay.
there, if you, I mean, O'Reilly in particular, you can find.
Well, the thing about, we have a relationship with O'Reilly where we get their permission to do this book for their books. So they know we're doing it. We've talked to the publisher and they know that we're doing it.
It's a great way to advertise, just I know some publisher we may get.
Yeah, in O'Reilly's case, they know. And they know we stream our sessions. And sometimes they give us free books too. Okay, so
that thing that I was talking about is local mode, right? They have there's a normal mode and a local mode. I don't know what the normal mode is called.
right. So you can do that if you'd like. And if you'd like to install Spark, the instructions are here on how to install Spark. If you don't want to install Spark though, you can launch what's called the Community Edition. And Databricks, if you go to their GitHub project, and the link is in the book, they will show you about using the Community Edition. And so we can go click here, and you can try the Community Edition, so get started.
Or, no, you can try the real edition.
No,
There's a free
but-
trial of the real edition, and then the community edition is just, it's free, but it's limited to 3 max users. Max
So you need to run it in the cloud on their system versus
Yes.
installing it locally.
Yes. So I
So you have your
already,
choice. You can install it locally on your own laptop, or you can run it in the cloud.
yes.
So it makes sense to wait a little bit and to try it locally at first.
No,
Well, I mean,
This is no cost. There's no.
yes,
the
I
community
understand, but
edition.
you said that it's 3 months and we have 5 months to study.
no. The Community Edition is not 3 months. You can try a full-blown version of Databricks for 3 months. The Community Edition is restrained, but it's forever. You can use it forever.
Do you know the big difference between the two?
They said it on the page. So if we go back
The
to,
free node is really wimpy, by the way. It's really wimpy. So you're not gonna go do a gigantic project on the free node. You just,
So what about if you
it's a
install?
low
on your-
world, you know.
So if you install on your machine the wimpy version, the full version?
No, if you have a decent machine, you'll get, more power, but these are.
so no collaboration, limit to 3 max users, public environment to share your work, meaning we're not securing it. There's a lot of reasons why a company wouldn't put their data on this, right?
6 gig is nothing.
What's that?
6 gig is nothing.
Yeah, right. It's just like we want to write some code and learn how it works, right? So, okay. So if you do that, you can follow the instructions, and they will. So they will show you how to get the sample data into the Databricks workbook, and they'll show you how to bring up a cluster. It's really easy. The only thing that's kind of a catch is in the samples, they assume that it's local and that you've installed everything in a data folder. In the Databricks Community Edition, your data is in this path. So when you read the script out, you have to replace the data folder with that full path, and then all the scripts will work. And you can load the data and follow all the instructions. And the way you do that is by opening up, a notebook off of your cluster. So I have the Community Edition someplace.
You're on the standard chart. Go back.
Yeah, that's weird. So if I go back to this, I logged in and then I had it. I don't know where my dashboard is. I have to go find it.
Okay.
You can try log in there again.
So I would expect that I would see like a dashboard or
I
something.
think you're not in community.
What's that?
Not community.
This
It's a
is,
regular one, it's not community.
Yeah, I know. I don't. So do you think it's community.cloud.databricks.com?
Just Google
Oh.
Databricks Databricks community.
Ooh. There it is. I'm back. Back, baby. So you can see, like, I've been working here a little bit, and you know, there's like some notebooks that they give you already that you can kind of work through to test your environment. And then there's sample code that the book gives you that you can run through. But if you click on that GitHub that is linked in the book and you don't want to type in any of the code, you can click on code, and then you can click on the chapter that you care about, right? And then in here, they'll show you some code that might be a code snippet. If you click the raw, you'll get rid of any of the HTML formatting that you might have. And then you can just copy and paste that into either, this is in the command window, or a notebook, or whatever you're working in. So just remember to do the raw version of it so that you don't have any weird symbols when you copy and paste code back in. The point is, when you're reading the book, like if you're over here, here, I'll make this a little bit bigger. Okay, and then, I don't know. But when you come over here in the book, you'll see, you'll see code here. And so rather than trying to type out the code, you can just go into the GitHub project, grab the code, and then copy it and paste it into your notebook. It will work. Does that make sense? Anything else you want to talk about? Oh, you want to see a notebook? Actually, I don't think, did I actually show you a notebook?
So no.
Okay.
And
oh, yeah, this is kind of a, so if we just do like, let's see. Create notebook, and then we just call like demo, right? Python, it could be a Scala, SQL, or R notebook, right? Most of the work we're going to demo in class is going to be Python. And then what cluster? This is a cluster that I already created. This is my 6 gig cluster that's running 5.2, which is Spark 2.4 and Scala 2.11 and Python 3. It doesn't show that. And then I click create. And then here, I can just type in code. And if I want to add another line of code, I just say like add cell below. And then if I want another one, I add cell below. So this could be multi-line. And then if I run code up here, just click here, will run just this cell, right? And if I want to run all the cells, I click run all, and it will run all the cells all at once.
We've talked about notebooks, I think, 3 or 4 different times now.
Yeah,
within TIG. But
I just thought I'd give them a brief
it's
introduction
good.
to it. The book will talk about notebooks too, some more too.
And it doesn't have to be just code. It can also be markdown type, comments, I guess, or notes or whatever on the code or on the results.
Yep.
So it's pretty much like usual Jupyter notebook.
Yeah, it's very similar. It's a little different. There's some idiosyncrasies with this that makes me miss Jupyter a little bit, I guess, where I'm like, oh, Jupyter would have done that better, but it's mostly the same. Yeah. Okay, so that's our agenda between now and August. By August, you guys will know Spark. Does that sound good? Any questions before we wrap up?
The funny stuff is when you try to search for O'Reilly Publishing and you go there, I did a few weeks ago, I couldn't find their books.
What?
If you search on Google O'Reilly Publishing, you go to their main O'Reilly page.
Oh, they don't have a list of titles. They don't have. Is that what you're saying? They don't have a list of titles.
I was wondering, where are they? Because a few years ago, I had like $300 worth of books.
So it looks like we don't have the ID on Anaconda portal, isn't it? With Spark.
We don't have what?
So I'm using Anaconda here, the integration for to launch different platforms. Looks like we don't have Spark here.
That makes sense, right? Because if you think about Anaconda, that's a set of libraries for running a problem. And here what we're talking about is a set of machines, right? Like you're talking about a much bigger thing. They're not gonna, the spinning up of machines on your machine is probably something that they don't like include by default.
So it's going to be a separate standalone installation. Right?
Yes.
Yes.
Yeah.
Do they have Scala on Anaconda now? Do they have Scala on Anaconda now?
Things I can't find anything here. So.
Oh, right. Anaconda is really like, scientific libraries, a collection of scientific libraries for Python, right? And in this situation, we're not talking about necessarily a library. We're talking like kind of an ecosystem. It goes beyond
Much
just a
bigger.
library.
Yeah.
I think that makes sense.
Oh, but that reminds me, if some of you might not be comfortable with Python, or you might want to brush up on some of your Python skills if you haven't used it for a while. And there are so many different ways of learning Python, but I like DataCamp. Now, DataCamp you kind of have to pay for, but if you search like Spark, there's a Spark library for R. It's called Sparkler, which always makes me laugh. So there are a lot of Spark courses here that are just like 4 hours long. And then there's a lot of like intro to Python courses that are like 4 hours long. So you can use DataCamp. I think it's like $10 a month or something. It's not that expensive.
Yeah, I mean, if you're taking an intro Python class, I think that's free.
Yeah,
There are certain tracks.
there's like 30 classes that are free.
Yeah. But if you're going to something more advanced, like a Spark or something, then yeah.
The book Deep Dive in Python 3, it's available for free, no PDF.
Oh, there we go.
Oh, yeah. I knew that
I
one.
think we did know that,
Yeah,
actually. We
yeah.
researched that when we were
Yeah.
doing Python.
And I was learning again some more about Python with something called Mega Tutorial for Flask. It's basically the most popular web framework for Python. It's fascinating. When you go
I don't know
to
if you can say most popular.
it's actually just became more popular than
Pyramid or Django.
Can you please put all this information on the website for Meetup?
Yeah.
Thank you.
Yeah. Now notice that we haven't talked about when our next meeting is. And here's kind of good news for us, but bad news for you. And that is both Scott and I, we've been traveling a lot, me a lot. But,
You way more than I.
yeah, like I'm flying out tomorrow at 7 in the morning. So I've been traveling a lot. So we haven't actually picked a day for the
I
next
thought you
session.
said that the next session we could go back to week 4.
I think we can go back to week 4.
Yeah, it was the one after that we were like,
Well, by the end of the week, I'll pick a day and I'll put it on the meetup for our May meeting. Okay. I apologize for the lack of communication, but we'll try to solve that. It's just like I've been all over the world, literally like Asia and Europe and all over the US. So it's been a lot of
We're
travel.
going to make it 6:30, especially for those driving down here. Parking
Yeah,
at 6.
we could take that feedback. Would you guys rather start at 6:30? Is that okay, or is that too late?
yeah, it
Traffic
probably
traffic goes down a little bit,
Yeah.
and parking is free.
Yeah.
I mean, I walk here, but I can tell you, that's usually a problem with many people coming downtown.
All right, we can try to do that.
Yeah, 6:30. That sounds good.
Yeah.
That's a smart thing because although the only issue there is the building closes, but I mean, you guys can have problems tonight, but
I came late one time and asked the guard downstairs.
yeah.
All right, thanks, guys. We'll see you guys.
You got
Thanks.
You know, I have an idea for next year.
What's that?
Electron.
What is it?
Electron,
Electron.
like from
No.
yeah, a way to write
Desktop app.
desktop applications using
JavaScript.
JavaScript and
Like,
How to suck up all your RAM?
what's the JavaScript?
Node.
I know, what's the JavaScript mobile application? Kotlin, thank you.
Oh, yeah.
It's like Kotlin for Windows.
Well,
apps.
the reason I fell into it is because I program in a very obscure language called Harbor, which is a descendant of Clipper.
Oh.
And
Hey, talk to Scott. I'm going to use the restroom. I'll be right back. I'm gonna-
Okay,
so
Harbor, I'm looking it up now.
if you go to a website called harbor.wiki,
Harbor.wiki, okay.
it's actually a website I created.
Oh, wait. I am not, okay, sorry, I'm trying again.
Are we still broadcasting? No, we're not.
No, I don't think so. Let me make sure. No, here I shut down. Oh, let me make sure. Stop sharing.